Do we track time? In the modern era with our modern technologies, surely it's easy, but we've been trying to measure time for thousands of years. Before atomic clocks, wristwatches, and the good old-fashioned grandfather clock, how did we get to where we are today? Let's begin at the beginning, when people first started to break time up and begin to measure it. The ancient Egyptians were the first, it seemed, that broke the day into 12 hours of light and 12 hours of darkness, which has remained throughout time, and you may even be familiar with this today with our 24-hour day. This was such a long time ago that there is no explanation as to why they divided the days in this way. The Egyptians, at first, used shadow clocks, similar to a sundial. Their giant obelisks could even be used as a clock. As the days elongated and shortened throughout the year, the 12 segments would increase and decrease as well. So a winter hour would have been shorter than a summer hour. The Egyptians didn't seem to break time down into further increments, like minutes or seconds. However, dividing time into units of 60 has been around for a long time. It is understood that this was used by the Babylonians, or maybe it was the Mesopotamians. Anyway, why is 60 such a good system that has stood the test of time? The number 60 has a lot of factors, and in particular, a lot of practical factors as well. 60 can be divided cleanly by 1, obviously, but also 2, 3, 4, 5, and 6. Having so many low factors makes things like having a half, third, or quarter of an hour possible, which is easy to measure and easy to break up. It's possible that 60 had some other meaningful meaning to these ancient civilizations. There just isn't evidence either way. The ancient second, though, is not the same as the second we have now. They were 60/60th of a day rather than an hour, so they are significantly longer and different than what we think of as a second now. The earliest methods of measuring time was using water clocks, candles, incense. None of these were great or super reliable and could end up widely out of time by the end of the day. For example, water clocks may freeze in cold climates. However, as the medieval period got into swing, big developments began to happen. Mechanical clocks had been around for a while, often using weights to pull gears. However, they were just about as reliable as any other method, until the verge escapement was coupled with the clocks in the 12th or 13th century. The escapement could slow down the turning gears and falling weights into something with incremental, consistent, and jerky movements. When escapements were incorporated, the clocks would only be out by around 2 hours by the end of the day, which was a fantastic improvement on its predecessors. The next game changer was the pendulum. Galileo spent much of his time studying pendulums and worked out that as the pendulum swung, it did so at a constant rate. He really wanted to make a clock using the pendulum but just couldn't get it to work. A Dutch inventor, Christian Huygens, who was inspired by Galileo, was able to come up with a way to ensure that the track of the pendulum was consistent, so that the time between swings would always be the same. The pendulum clock became super accurate, losing only about 15 seconds per day. Early improvements were different shaped escapements, which reduced the angle of the swing of the pendulum, as the biggest issue was that as the swing got larger, the path that the pendulum could follow may be different, and thus not be consistent. Over the next couple of hundred years, the escapements were advanced so it could deal with a pendulum with a smaller swing angle, meaning less chance of deviating swings, and more importantly, more accurate time. Like I said before, dividing a day into 24 hours has been a long-standing tradition, but breaking it into 60 minutes has not been done consistently throughout history. With the accuracy of the pendulum clock, though, minute hands became commonplace to have on clock faces. Why people went back to the base 60 time measurement is not exactly known, as people would normally divide an hour into half or quarters rather than 60 minutes. And it had been a long time since the Babylonians existed to when the minute hand became a thing. As the timekeeping devices became more accurate, the second hand became a common addition in the 18th century. As seconds were often used in scientific experiments to measure time, it became the base unit of measurement. And so, the question began to emerge of how long should a second be. It was meant to be 60th of a minute, which is then 60th of an hour, which is okay, and then there are 24 hours in a day. This is all straightforward until you realize that the Earth's rotation is ever so slightly slowing down. So if we were to peg all our time to the way the Earth rotates, then our timing system is never going to be constant. So institutions tried to base this on the length of a specific year, 1900. But nobody really liked this, as it's not like we can go back in time and check that our second was accurate. The second needs to be pegged to something that would never, ever change. In 1967, the definition of a second became the duration of 9,192,631,770 periods of radiation, corresponding to the transition between the two hyperfine levels of the ground state of the caesium-133 atom. I know what you are thinking, that this is a really simple and very accessible way to measure time. Basically, when one caesium atom is hit with a laser, one of caesium's electrons in the outermost shell will go back and forth between two states. This is the hyperfine levels talked about in the definition. So when it's just over 9 billion of these changes, this is 1 second. This is measurable, as when the electron jumps between the states it gives off a little electromagnetic pulse. This is the foundation of atomic clocks, because you are literally looking at the atoms to keep track of time. There is one big issue when using this definition for a second, and that is it has done exactly what it is meant to. It has separated the second from the length of a day, which is really where the second came from in the first place. The Earth's rotation is slowing. We have about an extra hour in our day than the dinosaurs did. And now, we, every few years or so, need to add a leap second to the year to ensure that the time stays in sync with the solar time. This is creating issues as a lot of smart devices that speak to one another need a synchronized clock, and sometimes the extra second memo just doesn't get to everyone at the same time. However, for the time being, this is the system we have, adding a second whenever the world slows down too much that is starting to get out of whack. Thanks for watching. If you enjoyed this video, hit that like button below. Or leave a comment on what you think would be the best timekeeping system. Would it be a base 100 like the French tried for 6 months, or something else? Let me know, and I'll see you later in another video.